Welcome everyone. Thank you for joining us for today's webinar. My name is Carrie Drummond and I'm the Marketing Coordinator for Ansible here at Red Hat. Today we're excited to share what's new in Ansible Tower 3.4, presented by Bill Nottingham, Ansible's Senior Principal Product Manager. Before we begin, I would like to go over a few housekeeping items. All attendees of the webinar are on mute. Questions will come up during the presentation, and we ask that you use the Questions tab on your control panel. We'll have time for questions at the end of the webinar, and we'll address as many as we can. We're also recording this webinar, and the recording will be shared with you later today or tomorrow. Now, without further ado, we'll turn this time over to Bill.
Thank you all for joining us today. As Carrie said, we're here to talk about what's new in Ansible Tower 3.4. This webinar will assume at least some familiarity with Ansible and Tower. If you do not have a lot of familiarity with Ansible, might I suggest our Getting Started Ansible Essentials webinar. We have that once a month. Our next one is on Tuesday, February 12th at 2 p.m. Eastern Time. We also have upcoming webinars, including things like Ask an Expert on Ansible Network Automation, NetApp modules for Ansible, and more. You can find more of those on our webinars page. So I'm here to talk to you today about what's new in Ansible Tower 3.4. We just released that this month, and we're pretty excited about the enhancements we have and bringing new capabilities to our users. So we enhanced Ansible Tower 3.4 in a few specific ways. I'll go through them here, and then we'll go through some demos about how you can use these in your environment to help you automate better. Three main ways we enhanced it. We did a lot of enhancements on workflows in Ansible Tower, allowing you to better model the automation processes you have and to reuse your automation in more flexible ways. We added job distribution via job slicing to allow you to scale jobs across your Ansible Tower cluster and run them in a more reliable fashion, and support for deployments with FIPS mode enabled to allow for deploying in secure or regulated environments. So just to go through some of that, here is Ansible Tower. You'll notice I'm looking at my job template and workflow template screens. First, we're going to talk about the ways that we've enhanced workflows in Ansible Tower. So I'm going to start by looking at one of my workflows. This is my production deployment workflow. And with this, we'll see one of the things that we've added to workflows, our workflow level inventory. If you look at this workflow, you'll note that I have set an inventory on this workflow, and I can also prompt for launch for an inventory. We did this to make workflows more flexible for our users. We often have people who have things like these application deployment workflows that they want to apply to any environment they have, that they want different teams to reuse them in different fashion. So as part of that, you can now set an inventory that is used for an entire workflow, or you can prompt at launch for an inventory. So I'm going to run this. It's going to ask me for an inventory to use across my workflow. I'm going to run it on my production cloud instance. You see I have a couple other choices here. So the way that this works is that any job that is in the workflow that has an inventory set as being promptable or overridable will use this inventory that I set for the workflow. And again, this allows you to do a deployment on any environment that you see fit, while still letting you override it for a specific task in the workflow, such as adding something to a load balancer or something else, which does not need to necessarily have the inventory overridden. So you can see this workflow is running now to deploy my simple 3-tier application, update my CMDB and my load balancer when it's done after running some tests. As part of this, you will see our next new feature that we added to workflows, what we call our workflow convergence nodes here, which you can see in the test step of this workflow. Again, this is for allowing you to more easily model the process that you actually have and make workflows more flexible for your use cases. So in this case, after deploying my 3-tier app of web server, database, and application, we can then run our test steps on the application after all 3 of these have finished. Again, this just makes it more simple to have your workflows model the processes you actually have. So you can wait for multiple steps to finish before proceeding in your workflows. Just like with workflows before, these steps can be based on whether these jobs succeeded or whether they failed. If you have cleanup steps, we'll have an example of that later, or they can be steps that run always regardless of whether the previous steps succeeded or failed. So here's my deployment. It worked. Yay, we've deployed the new version of our app. Next, I'm going to go back to our template screen and launch a different workflow to show the final new feature that we added to workflows. So here we have my deployment pipeline. I'm going to launch this, and you'll see a little something different in this workflow screen. I apologize, since this is a little complicated of a workflow, we're going to zoom in a little bit so you can see. So if you look at this workflow now, you'll see that we have different steps in this workflow, and you see this little W button here. This is because one of the things we added was the ability to have workflows inside your workflows. Because again, we have people that have workflows that they want to reuse in different contexts. I had my production deployment workflow that I just ran earlier. So obviously I want to have that as part of a pipeline that I run where I can, as you can see, I can do a deployment to my development environment via my deployment workflow, run some tests. If they fail, roll back my deployment. Otherwise, we can proceed through our pipeline, through deploying in our test environments all the way through production. By allowing you to reuse workflows in this fashion, we allow you to build these more complex pipelines and more complex workflows out of individual components that could be maintained by different teams or others inside your organization. We have many customers today that have different app teams which each maintain their own deployment workflows, and then they can have their operations teams use these different workflows of their apps teams to properly deploy their infrastructure as part of a master workflow. This could be just deploying multiple applications on one machine, or this could even be a global workflow for rolling out a new data center that has different workflows inside it for setting up the networking, the DNS, the load balancers, the applications, the infrastructure, etc. Again, it's all about allowing you to take the automation you have and use it more flexibly and in new ways shared across teams. So you'll see that our workflow is going and we're running a pipeline deployment across our infrastructure. So that's what we've done to enhance workflows in Ansible Tower 3.4, but there's other things we've done as well. And now our deployment here is finished. So I'm going to talk a little more about job distribution via job slicing. So if you've run jobs across Tower in the past, you'll know that they run much in the same way that Ansible does. If you have a job or a playbook run, it runs as a single Ansible playbook task on a single node in your Tower environment. So for example, if you want to do something like gather facts across thousands of machines, if you want to update a configuration on your estate of 10,000 network switches, it's going to run a single Ansible playbook that talks to those thousands of machines or 10,000 switches. This can be a very resource-intensive task. And what we wanted to do with job distribution via job slicing is allow you to do that in a way that better scales across your environment. So I'm going to take an example job here. Here's my fact gathering job that runs across my production cloud instance and gathers facts on all my instances. Now, in this production cloud environment, I have about 2,000 some hosts. So that can be a pretty expensive job to gather like a few megabytes of fact data across all those hosts. So what we added is a new feature that we call job slicing. When job slicing is enabled, as it is here, you can see it's set to run as 10 slices. It takes this job and splits it up into 10 smaller jobs or slices. This means that we split the inventory equally into 10 slices and run individual playbook runs across each slice of that inventory. Those slices will then be distributed across my tower cluster. In this case, this is actually a single node environment, so it's just being distributed across a single node. But if you have a 10, 15, 20 node tower cluster, these jobs will be spread equally across the cluster. This allows you to run smaller jobs both more reliably and faster and more efficiently across your tower infrastructure, allowing you to automate at scale easily and reliably. So apologies, going back to this job. Now, if I'm going to launch my fact gathering, what you'll notice is that this actually is a workflow in miniature scale. So it takes what is just your standard job, which is a single playbook run, and splits it into a workflow of 10 different job slices that are all going to run before it's finished. Just like any other job, you can pass any prompting or configuration that you need to this. You can include it as part of a workflow, but it allows you to spread this job across your cluster to perform more reliably. I will note that these sorts of jobs are only relevant for things like individual configuration management, fact gathering, and other jobs where you are not doing complex cross-host orchestration. As each job slice is its own Ansible playbook run, each slice must be independent of actions going on in other job slices. So you'll see that now this is running to gather facts across all the hosts. This will take a minute or two again because it's running across some 2,000 nodes on our cloud infrastructure here. Finally, the last thing I'd like to talk about is our support for deployment in FIPS environments. FIPS is a standard produced by the US government. It's a Federal Information Processing Standard. It is a standard that describes how secure environments should be run, regulating things like encryption algorithms and key sizes used when doing encryption in a secure government. By making sure that they control the encryption algorithms they use, they make sure things stay secure. Now, if you're running on Red Hat Enterprise Linux, it supports deploying in something called FIPS mode, which is running in this secure mode. So what we've done with Tower in 3.4 is we've enhanced Tower so that it runs when Red Hat Enterprise Linux is deployed in this secure mode. I'm going to run a job that actually checks this to make sure I'm operating correctly in FIPS mode, but it's actually going to be queued behind that fact scan that I was just running, so it may not finish in right away. As noted, this is now queued, so it will finish later. But the point of this is, though, if you're running in these sort of regulated, secure environments, you can use Tower to do all your automation without any problems. So that is Ansible Tower 3.4 in a nutshell. Again, it's about allowing you to use workflows to automate in all the ways that you need and reuse your automation in new ways. Using job distribution via job slices to allow you to scale large-scale automation tasks across your Tower cluster and allow you to deploy in secured, regulated environments that are using things like FIPS mode. There are a few other notes and caveats. This is cribbed from our Ansible Tower release notes that you may want to be aware of. We have removed some deprecated features, such as deprecated cluster management commands and deprecated older style authentication tokens. Here you can see some of the new commands that you use that have been available for a while, including new OAuth 2 tokens that were introduced in Ansible Tower 3.3. We have made a minor adjustment to how workflow failure is calculated. Now, if any step in your workflow fails and is not caught by a rescue step, the workflow will be marked as failed. So you can more easily see what the status of the workflows in your infrastructure. We've updated how we use Google Compute credentials to match how upstream Ansible does. And there are a few deprecated read-only API fields that you can see in our release note. So that covers what's new in Ansible Tower 3.4. I will be happy to go through questions at this time.
We do have a few lined up.
Okay. So there's a question on the convergence nodes that if one of the three options fails, does it stop the workflow from proceeding? Currently, the convergence step is used for ordering, and the next step will proceed if any one of the preconditions fails. Preconditions is succeed. So in that case, if one of the jobs succeeds, it will wait for all three of them to finish and then proceed. We are looking to make that configurable in the future. There's a question on job slicing and whether it works with isolated nodes. Each job slice is distributed according to the instance groups and isolated configuration for that template or project or organization. So it will use isolated nodes as configured. There's a question on rollbacks for tasks for multiple clouds. We are very explicit about how we handle rollbacks in Ansible automation. So there is not any real built-in rollback primitive. The workflow I showed you with the rollback was actually an explicit rollback playbook that would run to roll back the environment that I just deployed. Because automation can do many different things, we want you to have control about how specifically you roll back your automation in your environment, whether you explicitly uninstall a new application and reinstall the previous version, or your rollback could be just tearing down a set of cloud instances and pointing a load balancer back at the previous environment. We want you to have that level of control, so we let you define your rollbacks in that way. There's a question about significant cluster changes between 3.2 and 3.4. So most of the work in our clustering that's changed between 3.2 and 3.4 involves the introduction of deployments on OpenShift. That allows you to deploy on OpenShift and scale up and down at runtime. There are some features around this that are added. When you are defining how instance groups work to segment your capacity, you can now define them in terms of percentages. So you can, for example, allocate 50% of your cluster capacity for your development team or 40% for your operations team, etc. You can also, as of 3.3, create new instance groups and organize your capacity at runtime without having to rerun the setup playbook. So that was a large change. That was actually introduced in 3.3. There are no specific cluster changes between 3.3 and 3.4. Question on upgrades and how painless they are. Yes, the upgrades from 3.3 to 3.4 should be painless, and depending on the size of your environment, can complete in under 5 to 10 minutes. Should not be a problem. Question about having approvals embedded in the workflows. This is not something that is in workflows natively. However, this is a thing you can do if you code them carefully. What we usually suggest to people is that if your approvals come from a third-party system, such as a ticketing system or some other tool like that, Ansible has a couple of modules for hitting remote URLs and URIs via REST and other mechanisms to get data. So you can have a step in your workflow that is just a playbook task that checks your remote ticketing site or remote website for a flag or whatever data that is needed to tell it that it can proceed. Question on how you scale and how clusters work for scale. So the way that Tower Cluster works is, excuse me, is that you have a cluster of multiple tower nodes, and each of this adds new task running capacity to the cluster. You can then use something that we call instance groups to divide that capacity. So for example, in my cluster of 10 nodes, I could have 5 different instance groups of capacity, each of which contains some subset of those nodes. So I can reserve capacity for my development team or my operations team, or even reserve capacity just for a specific set of playbooks that are used for a specific purpose. We then have what we call isolated nodes, which are nodes that live outside of the cluster but are used for job running capacity. These can be deployed in foreign data centers. These can be deployed in foreign network zones that you have to jump through a DMZ to get to, or these can be just deployed locally as nodes that you more easily bring in and just use to run jobs. These again can be segmented into groups for capacity management, but the way that they work is you have the master tower cluster that sends jobs to these isolated nodes for running and then collects the results afterwards. Question on doing upgrades. You should be able to upgrade from a 3.2 cluster to 3.4 directly, assuming you are staying on a standard cluster deployment. If you want to move from a standard cluster deployment into OpenShift, there's a little more work that's involved, and Red Hat support can walk you through that process. There's a question about the API showing things like where the job is executed and its start and end time of the job. All of that is available via the Ansible REST API. And specifically, if you go to API v2 jobs and pull the job ID for the job you're looking for, all of that information is there. There's a question on using a survey on a job template and using that when scheduling. That was added in Tower 3.3. Anything that you prompt on a job template can now be prompted and set when scheduling a template. So you can, so for example, if you have multiple versions if you want to schedule multiple configurations of a job, each with different parameters, you can now do that. Question on clustering and high availability in 3.4 and replication of the database node. As before, that is a thing that you can do. It is not directly configured as part of the installation. Generally, we leave advanced database management as a thing that the customer can do. And there's a question on using tagging in VMware inventories to filter them. There are a variety of instance filters supported for the VMware inventory. I believe tags is part of that. I believe there are some examples in the documentation, and if not, Red Hat support can walk you through that. That appears to be all the questions that I see today. So I want to thank you for joining us today, and hopefully this was helpful for you. And we have a variety of webinars in the future, so I'm going to throw this back to you, Carrie.
Yeah, I do just want to give one other update. If you haven't seen the news, we announced the save the date for Ansible Fest 2019. We are heading to Atlanta in late September. The dates are September 24 through 26 in 2019. So you can head to ansible.com/AnsibleFest and sign up for notifications to learn when the call for speakers opens, when tickets go on sale, and we'll just generally keep you updated on any major milestones. So wanted to make sure that you all knew about that. This webinar today was recorded, so we will have that up online and we will send the link out to you either later today or tomorrow. So if you want to review or share with any of your colleagues, you'll be able to do that. And I think that's it. Thank you so much, Bill.
Thank you.
And thanks to everybody for joining us. Have a great day.